to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the snap ring for steady-state thermal analysis. We will start by double-clicking on steady-state thermal. Next, I'll go to engineering data. I'm going to create a new material, that is carbon steel. The property required is isotropic thermal conductivity. The value of isotropic thermal conductivity for carbon steel, that is ANSYS 1070, which we have already used for static structural as well as modal analysis, is 51.2. The website which I had given you before does not contain this data. I found it in some other literature, so you can use this data, that is 51.2 watt per meter degree Celsius or watt per meter Kelvin. The units mean the same. So next I'll go to project and update projects. Next I'll go to geometry and right click. Import geometry of the snap ring. Next I'll go to model and double click on it. First I'll allocate the material as carbon steel. Next I'll go to mesh and change the sizing to fine and update. Now if you recollect, the snap ring sits on a particular object which you want to hold to a particular zone. You can just go through the video of static structure and you will understand the explanation for the use of the snap ring. So accordingly, you will understand that this is the area where you want to apply a temperature. So here I am going to insert temperature. Now for the carbon steel that we are using, the maximum temperature that the snap ring can bear is 315 degrees Celsius. On the rest of the surfaces, I am going to insert convection. Right click, insert convection. Now here I am going to give the value of film coefficient as say 0.032 watt per mm square degree Celsius. This is the film coefficient for air. So I'm just giving it air cooling. So that's the boundary condition required. Next I'll go to solution and I'm going to insert thermal temperature. Also I will insert total heat flux. Next I'll solve. The first result you can see here is of temperature. You can animate and see the result. The various values of temperature have been given on the left hand side. If you want, you can use the probe option for finding out the temperature at various zones, or you can just click on max min, so it will show you where the temperature is maximum and where it is minimum. You can again click on max min so that the options disappear. Here is the probe option. You can use it for finding out the temperature at a particular zone. For example, if I want to know here with this color, what is the temperature? It is 194.82 degrees Celsius. Similarly, if I want to find out for this yellow color here, what is the temperature? It is showing 260.43 degrees Celsius. Yellow is between these two values and this green was between these two values. So approximately you got some. Now if it is not green, it is the cyan blue color, then you will have the values from here. So accordingly, you can just see which green color or yellow color or whichever color it is, and you can just match the values from this zone, or you can just use the probe option for clicking and figuring out the temperatures. If you don't want to see these options, you can just click on delete all. It will be deleted from this zone. Next, I'll see the total heat flux over the body. The maximum heat flux over this body is 24.324 watt per mm square. You can animate and see the result, how the heat transfer takes place. So these are the various heat flow over the entire body. So it is just changing over a particular area. So you can just click somewhere and you can just find out what is the total heat flux. But roughly the value is 24.324 watt per mm square, and the minimum value is 3.9739 watt per mm square. So that's what you obtain here. Now this is by using carbon steel as the material. If you change the material, you will get different values of temperature and total heat flux over the body. Now there are various materials used. Since I have not changed the material, I will just change once and show you. Suppose instead of carbon steel, if I import a new material, there are various other materials that are used. Say if I use stainless steel as the material, just click here. You can see it is bookmarked. Go back to projects and update projects. You can see all the arrows over here change to a green tick. So you can go back to the mechanical window. Here you can change the material to stainless steel and solve once again. So when you go to temperature, you will see the variation of temperature. These values have changed. Also, this minimum value has changed over the body. You can animate and check the result once again. And for total heat flux, you will see that the maximum value is 15.1 watt per mm square. Previously, it was higher. And the minimum value is also changed. It has become even more lower. It is 1.326 watt per mm square. So by using two different materials, you can see the variation of temperature over the body and also the total heat flux which is taking place over the entire body. So with this, I end the session. I hope you have understood how to analyze a snap ring for its thermal analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.